Hello everyone, welcome to week 5. This week we will learn about process costing, which is in chapter 5. And in this chapter you will learn some terminologies such as conversion costs, equivalent units, inventory flow assumptions. And you need to practice some problems where you need to use one cost flow chart, which is a little bit long. So what I did, I actually prepared the cost flow chart format for you. I already posted that one on Blackboard. So when you will be practicing the problems, I would request that you will print out that cost flow chart and then you will practice the problems. And of course, during the exam, I'll also provide you this cost flow chart. So you don't need to memorize all those titles, column and row headings. You will see some highlighted cells. You just need to fill out that cells. But before practicing some problems, let's get some idea about process costing. So process costing system is used by the manufacturing companies that usually produce similar type of items, but they produce huge or bulk amount of productions. For example, paint manufacturers or cereal manufacturers, ketchup manufacturers, they produce similar type of item, almost identical product, but they produce mass productions, huge bulk amount of productions. For example, Heinz company, one of their product is tomato ketchup, so they probably manufacture thousands, millions, billions bottles of tomatoes, and all those bottles are kind of similar items. So for these type of process costing systems, companies usually do not calculate the cost for each and every product very precisely. Rather, they calculate the total cost for huge amount of productions or for all units, and then they actually take the average costs. So now we will see some differences between job order and process costing. So if you remember from the previous chapter, job order costing is used by the companies that actually produce unique or customized products, and they usually produce only few number of items. On the other hand, process costing is used when companies use similar type of products and they do mass productions. So you should have some idea about this chart. So for any production process, you need to calculate these three types of costs: direct material cost, direct labor cost, and manufacturing overhead cost. Now you can try to imagine the production process of your company. You can try to imagine the production conveyor, production belt, where you will see that direct materials are added and you will have the labor force who are working there. You will have some manufacturing overhead items. So when the products are under production or in the production conveyor line, we call it work in process. Once the production process is done and the product is completely finished, we call it finished goods. And for a certain period of time, if you sell certain number of goods, you can check what is the cost of those goods that you sold, which we call cost of goods sold. Now for job order costing, you need to calculate these three types of costs for each and specific jobs. On the other hand, for the process costing systems, you need to calculate these three types of costs for every processing department. So for example, in this chart you will see that one company, they have three types of jobs, for example. So they're gonna calculate all these three types of costs, which are direct material costs, direct labor costs, and manufacturing overhead costs for these three specific job 100, 101, and 102. On the other hand, the company that is using process costing system, they will be calculating these three types of costs for every processing department. For example, here you will see they have several processing departments and they're gonna calculate the costs for every processing department. Now we will take one example. this example is one of the candy company, Jelly Belly company. So they produce these delicious candy beans, and they use process costing because they usually produce almost identical candy beans. They may have different colors and flavors, but those are not kind of like very unique or customized. So they usually have similar type of products, and they usually produce like huge or mass productions, billions pounds of Jelly Belly beans. So what they will do, they will actually calculate those production costs, three type of production costs that are direct material cost, direct labor cost, and manufacturing overhead cost for every processing department. And they will take the total cost, then they will divide it by what's the total amount of productions. This is how they will average the cost for every product. For example, the Jelly Belly company has three processing department. One is center processing, where they actually produce or process the inside materials, and then they have their shell processing, where they actually make the coating or the shell of those candies, and the third department is their packaging processing department. So for every department, they will calculate what is the total cost and how many jelly beans they actually produced. For example, you will see for the center processing department, their cost is $1,350,000, and they actually produce 1 million pounds of Jelly Belly beans. So they actually divided the total cost divided by the total number of production or the total amount of productions. This is how they got their cost per pound in the center processing department, which is $1.35. This is how they calculated cost under the shell processing department, which is 80 cents. They also calculated their packaging cost per pound, which is 70 cents. And then they will add all those costs, and the total cost per pound Jelly Belly bean is $2.85. Now in next slide, I'll show you a video and you will get some idea about the production process of this Jelly Belly factory.
I'm Mr. Jelly Belly, America's favorite gourmet jelly bean. Did you know it takes 7 to 10 days to create a Jelly Belly jelly bean? Well, I'm here to show you how our world-famous jelly beans are created. Follow me! The Golitz brothers began making candy in 1898. This family business has produced the finest candy made in America for 4 generations. Candy making is a creative blend of science and art. The ingredients for producing Jelly Belly jelly beans are carefully chosen to maintain Jelly Belly's high standards for consistent quality. Jelly Belly gourmet jelly beans start with master confectioners that cook a flavored slurry for our delicious centers. We're not just flavored shells like standard jelly beans. Each batch is evaluated by quality assurance specialists for consistency. We use natural ingredients for flavoring whenever possible, like fruit purees, natural fruit juice concentrates, peanut butter, coconut flakes, and even real chocolate. When my candy slurry has passed inspection, it flows downstairs from the kitchen to this machine, which is called a mogul. The mogul deposits the precise amount of cooked slurry into the molds. Each one of these trays filled with cornstarch is imprinted with 1,260 impressions of my famous Jelly Belly shape. This is how I get my terrific figure. Now we go off to the dry room, which is precision controlled for temperature and humidity. We rest in here overnight so we can firm up our famous Jelly Belly centers for the next production process. The following day, we shake off the cornstarch from our Jelly Belly bean centers, and then we get to take a ride on the conveyor belt for a refreshing steam bath and sugar shower. Whee! Each one of our tender centers is now sugar protected, so we won't stick together. 25 pounds of delicious Jelly Belly centers are poured into each one of these trays. Then my friend rolls us into a rest and relaxation area so we can season up for the next production process. Here we are in the engrossing department. This process is how we build up our colorful soft pan candy shells, which takes about 2 hours. In these specially designed stainless steel drums, we spin and rotate while freshly prepared flavored and colored syrups are hand poured onto our centers. My candy making friends check to be sure each and every bean is coated to perfection. Our centers are coated 4 times with flavored and colored syrups and granulated sugar for drying. We are really shaping up now. Just a few more steps in the process and we'll be ready to see the world. Our candy making friends gave us a coating of syrup to smooth us out and then added a touch of confectioner's glaze to polish us to a colorful, jewel-like finish. Ah! To make sure that each Jelly Belly bean is perfect, we all go into this machine, which checks each bean against Jelly Belly standards for size, letting only the perfect beans fit through the screen. Any beans that don't make the grade are belly flops. But we don't stop there. Next, the beans are inspected by hand by a quality assurance specialist who picks out any imperfections. This special process gently prints our name on each Jelly Belly bean. We're all lined up, ready for our seal of approval. Remember, my name on our jelly beans is your guarantee that you are enjoying the original Jelly Belly Gourmet Jelly Beans. Now we are ready to be packaged for shipment all over the world. A large percentage of Jelly Belly beans are packed in these bulk cases of 40 individual flavors and shipped to retail stores. Don't we look beautiful? Yahoo! This specially designed machine is getting us all bagged up and ready to go. Jelly Belly jelly beans are packaged in special flavor mixes in a variety of bags and boxes. A family favorite is our famous gift box. This way, you can try your favorite flavors and perhaps something new. Our Jelly Belly menu comes with each gift package, so you can enjoy recipes combining Jelly Belly flavors for a real gourmet treat. We opened our first factory in the Midwest in 1898. It's been a sweet life. The Golditz name has been associated with quality candy making for over 100 years. Today, we make over 150 gourmet candies. All of our famous confections are made in America and enjoyed all over the world. I'm proud to be Mr. Jelly Belly, America's favorite gourmet jelly bean. See you at the candy counter.
Now we will see one example from our textbook. So if you remember the three types of costs properly, which are direct material cost, direct labor cost, and manufacturing cost, you could also classify those costs into two ways. Direct material and direct labor, these two costs together are called prime cost. On the other hand, direct labor and manufacturing overhead costs, these two together are also known as conversion costs. So in this chapter we will actually assume these two costs together, and we will call that as conversion costs. That means conversion cost is equal to direct labor cost plus manufacturing overhead cost. And we will also learn one terminology which is called equivalent units. So when we do our production, we'll see at the end of every day or at the end of a certain period, we will have some work in process inventory. Work in process inventory means the inventory which is still under production process. That means we actually added our direct material, and we also spend our direct labor cost, and some part of our manufacturing overhead costs are also incurred, but the product is not completely done yet. So this type of inventory we call work in process inventory. So at the end of the period, we will check what is the amount of our work in process inventory and what percentage of production process is actually completed, and based on that we will convert those work in process inventory into some equivalent units of finished products. Let's take one example, and this example is a swimming glass manufacturing companies, and they follow process costing systems. And when they follow process costing system, they actually follow 5 steps. Step number 1, you have to summarize the flow of the physical units. Step number 2, you have to compute the output in terms of equivalent units. Number 3, summarize the total costs to account for. Number 4, compute the cost per equivalent unit. And number 5, assign total costs to unit completed and to units in ending work in process inventory. So we will follow all these 5 steps when we will be solving the problem in this chapter. And for solving the problem, we need to follow one specific cost flow chart that I already posted on Blackboard. So I'm repeating, when you will practice some problems, you have to print out that cost chart format, and you will do your homework and practice problem on that chart. And during the exam, I will also provide the chart to you. It's a long big chart, but I will highlight the specific cells that you need to fill up. Now for this company, the name of the company is Seaview, and they actually produce these swimming glasses, and they have two processing department. Their first processing department is shaping process, and second department is insertion process. So now we will see this example, and here you will see the first step where we need to calculate the flow of physical units, and then we will check our second step where we will convert those physical units into equivalent unit. So they just started their business, so their beginning working process is 0. Then you have to add the production that they actually started during that period. So this chart is for the month of October. It's only for 1 month. So on October 1, they just started their production process, so there is no beginning working process. And then throughout the month of October, they actually started another 50,000 units. So these two together we will call total physical units to account for. Now During the October, they actually completed 40,000 units. And those 40,000 glasses are completely done, and those are transferred out to the next department. And the rest of these 10,000 units are still under production. And these 10,000 units, we actually call those as ending work in process. So now we actually convert these units into equivalent units, equivalent completed or finished units. So for these these 40,000 glasses or units, those are completed. For those 40,000 units, we actually spend all those direct materials and all the conversion costs, which means the direct labor and manufacturing overhead costs, those are also incurred. So for these completed 40,000 units, we will consider the entire 100% of those 40,000 units for their direct material and for their conversion cost perspectives, because these are already completed. 100% production process is done, and we actually spend 100% direct material cost and 100% conversion cost. Now how about these 10,000 units, which is still under production, and we call it work in process? So the assumption here in this example is that all those direct materials are added at the beginning of the production. That means when they started these 10,000 units, they actually added all the direct materials. Although these 10,000 units are still work in process, but the direct materials are added, so the direct material costs are completely incurred. So for this direct material column, we will consider those entire 100%. That means all 10,000 units. But the example also says that the work in process production is done by 25%. That means they still need to do the rest 75% of the tasks. So the product is done by 25%. So when we will be considering the conversion cost, we will consider this unfinished or work in process as per the percentage of production which is completed. Since for these 10,000 units, 25% tasks are completed, so we will consider 25% of it, and this is how we are converting this ending work in process into equivalent completed units. So these 10,000 units, which is also under production and not yet done completely, but 25% tasks are done, so we can call these 10,000 ending work in process. These are equal to 2,500 equivalent units. Now we will check the costs. Remember, the previous slides were all units. These are units. There is no dollar value. All these are physical units. Now, for these units, we will check our costs. So this table is showing the total costs. So for the beginning work in process, they didn't have any beginning work in process, so the costs are 0. But throughout the month of October, they actually started productions for 50,000 units, and of course they have some costs. So the total direct material costs for all those units are $140,000. So we are adding it plus costs added during October, and the conversion costs was $68,000. Remember, conversion cost means direct labor and manufacturing overhead costs. So we will call it total costs to account for. That means this is kind of the maximum cost that you will have. And this is column B is our direct material column, column C is for conversion column, and column D is the total column. Now we will actually convert those costs in terms of equivalent units, right? Because this cost is the total cost that we got from step 3. This is our step 3. You remember here, direct material total cost to account for is $140,000 and conversion cost is $68,000. That's what we are doing here, the total costs to account for, which I just copied from my prior chart. Now we will divide it by total equivalent units. These equivalent units, we got it in our first table. So if I go back for here, equivalent units, so for direct material, our equivalent units was this 40,000 plus 10,000, which is 50,000. For conversion cost, our equivalent units are 40,000 plus 2,500, which is 42,500. So now what we'll be doing, we will divide these total costs by total equivalent units, which are from our first table. And this is how we will calculate cost per equivalent unit. So this is our total costs to account for 140,000. I'm talking about direct material, and our total equivalent units are 50,000. So if I divide 140,000 divided by 50,000, our cost per equivalent unit for direct material is $2.80. And for the conversion costs, this cost per equivalent unit is $1.60. I'm repeating, we got these equivalent units from the first table, and we got these total costs from our second table, and this is how we just calculated cost per equivalent unit. Now we will actually take that cost per equivalent unit, and we will also show the products those are completed and the products those are still in as a work in process. We will show the cost of those products. For example, products that are completed, we know 40,000 units are completed, and for those 40,000 units we actually spend all those direct materials, and for these 40,000 units the entire direct labor and manufacturing overhead costs are also incurred. Now we will consider these units. Again, these are from our first table, and then we will multiply it by cost per equivalent unit, which we got here in our previous tables. For direct material, cost per equivalent unit is $2.80. For conversion cost per equivalent unit is $1.60. So this first part of this table is for the product that are completed and transferred out. So we took these units from first table and we got all these cost per equivalent units from our previous table, and you just need to multiply this. So the equivalent unit that completed and transferred out, if we look at the direct material column, that was $40,000, and we also got from our prior table that cost per equivalent unit for direct material is $2.80. So if we multiply these two, we will find that the cost that is assigned to the completed and transferred units are, for direct material, it's 112,000. And we can do the same thing for conversion cost. This 40,000 conversion cost, we got it from table 1, and from our previous table we got this cost per equivalent unit for conversion cost is $1.60. If we multiply these two, we'll figure out what is the cost assigned to the units completed and transferred out, and for conversion purposes it's 64,000. And if we add these two numbers, we'll get that the total cost assigned to the units that are completed and transferred out is 176 units. So this first part of this table is for the units that are completed. Now we will look at the units that are not completed. That means those are still as a working process, and we actually converted those under production or working process inventory into equivalent units. So if we can go back to our first table, you will see that for direct material, the equivalent units are 10,000. So try to understand the concept. For direct material, all those direct materials are added at the beginning of the production process. That means for those unfinished products, 100% direct material costs are already incurred. So that's why, although this is incomplete product, we are considering the 100% and we are calling that entire 10,000 as the equivalent units. On the other hand, for the conversion cost perspective, we mentioned it earlier that the production process is 25% done, and that's why we actually converted those 10,000 unfinished products into equivalent units by taking 25% of it. That means theoretically we will assume that 25% conversion costs are incurred for those working process inventory. So this is how we got the equivalent units from our first table, and now we will be multiplying this cost per equivalent unit from the prior table. And for direct material, equivalent units in ending working process is 10,000 times the cost, which is $2.80. So the direct material cost for ending working process is 28,000. And in the same way, we will figure out that the conversion cost for those ending working process is 4,000. Now if we add these two, we will find that the ending working process, as the cost that is assigned to this ending working process together is $32,000. Now we will add these two costs, 176,000 plus 32,000. The total cost is 208,000. So this is one example. I know it looks a little bit clumsy, but I hope you will follow the two practice problems that I already recorded and posted on YouTube, and you will watch the videos, solve the problems, and do the homework problems. And of course, before doing this, you will print out the cost flow chart from the blackboard.